The Earth ain't flat. I shouldn't need to say that. I find it astounding that in the 21st century, there are people in the world who are stupid enough to think that it is. But apparently there are. There are many ways of proving the Earth is not flat. In this video, I'll show you 3 of them. The first proof is a great experiment conducted by Slice Barkane, link in the description. In his experiment, he had 23 people from around the world measure the angle of the Sun at its highest point. If the Earth is flat, lines drawn at these angles should all intersect at the same point above the Earth. As we can see, they clearly don't. Next, he wrapped these measurements around a circle and found that they were all within a degree or so of parallel. This provides good evidence that the Earth is spherical and the Sun is a great distance away. To be fair though, you could come up with a shape for the Earth where the lines would converge somewhere near the Earth. Of course, the shape would need to change every day for this to work, and the shape would never be flat. Looking at the Sun and stars has the inconvenient problem that they're essentially point sources of light. What we need to be looking at are things that cover a significant area of the sky and have a definite shape. Constellations are perfect for this. Consider the constellation Orion. Any constellation will work, but I'll use Orion for convenience. A quick search of the internet and you can find countless photos of Orion taken from all around the world by amateurs and professionals. In fact, assuming it's the right time of year for Orion to be visible at night, you can take a picture of it yourself. The important thing is, no matter where you take the photo from, every single image of this constellation has identical proportions. This cannot happen if the stars in the constellation are near the Earth. If the stars are on the surface of a dome, the angles between the stars will change depending on where you're looking at it from. If you're not directly perpendicular to the constellation, it will appear flattened. If, on the other hand, the stars cover a 3-dimensional patch of sky, there will be parallax between them. There is no possible geometry that would work other than the stars being a huge distance from the Earth. Flatheads like to say the horizon always rises to eye level.
No matter if you're on the ground, on top of a building, a mountain, a hot air balloon, an airplane, or looking at high-altitude amateur balloon footage, the horizon never fails to rise right to your eyes.
But does it? Have they ever tried measuring it? No, of course they haven't. If they had, they would know that it doesn't. This is easily proven with nothing more than a camera, a suitable place from which to take a picture, and some basic geometry. Consider a camera at some height h above a flat ground. By the assertion of the flatheads looking directly horizontally, you should see the horizon. Next, if we're going to measure the position of the horizon, we need to have a point from which to measure it. I'll call the distance from the camera to the reference point D0. Next, we need another point at some distance D1. A line from D1 to the camera will cross the image plane at a height I'll call H1. From the law of similar triangles, we can see that the height of the horizon is h equals h1 times d1 over d1 minus d0. Knowing this, we can use a photograph with objects at known distances to calculate where the horizon should be if the Earth is flat. I took this photograph from the Empire State Building a couple of years ago. This is just a holiday pic and I didn't take it with any thought of flat Earth arguments, so it's not perfect for this purpose, but it'll do. If I just look at the top right-hand corner, there are a number of very clear landmarks that I can use for my measurements. If I look at this corner of Liberty State Park on Google Earth, and then draw a line from the Empire State Building through this point and extend toward the wharf in the background, I have all the points I need to find the location where the horizon should be if the Earth is flat. From Google Earth, we can find the distances D0 and D1. These are 6.3 kilometers and 11.3 kilometers respectively. I can substitute these values into my Euler equation, and I get h equals 2.26 times h1. So, what is h1? Since the value 2.26 in the equation is unitless, I can use whatever unit I choose for the h values. In this case, pixels are the easiest. The corner of Liberty State Park is 619 pixels from the top of the image. The wharf is 416 pixels from the top of the image. This gives a height h1 of 619 minus 416, or 203 pixels. Multiply this by 2.26 gives a height value h of 459 pixels above the lower line. Subtract this from 619 gives a value of 160 pixels from the top of the image. Clearly this is well above the actual horizon. To be fair, my measurements may not have been exact. My distances may have only been approximate. Okay, let's say the measurement error for my distances was 200 meters. Working through the math would still put the horizon somewhere in the green band, clearly higher than the actual horizon. From this, we conclude that the Earth is definitely not flat. So, will I convince the hardcore flatheads that the Earth ain't flat? Of course not. Their cognitive dissonance is too strong to be swayed by such things as facts. This video isn't directed toward them. The real worry is that people will watch their videos and actually believe them. There needs to be some reality available to counter the flatheads' bullshit. Anyway, if you like this video, click that like button. If not, click it anyway. What'll it kill you? Till next time, if it looks like bullshit and it smells like bullshit, it ain't a duck.